Hello everyone, welcome to this video. In this video, we are going to learn about XGBoost using OpenMathAI. So, let's get started. What is XGBoost? XGBoost is a powerful machine learning algorithm used for regression and classification problems. Unlike a single decision tree, which makes predictions using only one tree structure, XGBoost combines multiple decision trees to produce a more accurate and reliable prediction. XGBoost works using a technique called gradient boosting. In this method, decision trees are created one after another. The first tree makes an initial prediction, and the next tree learns from the errors made by the previous tree. This process continues across multiple trees, with each new tree helping to reduce the remaining prediction error. During prediction, the input values pass through all the trained decision trees. Each tree produces a small prediction value, and XGBoost combines the outputs from all the trees to calculate the final predicted result. XGBoost also uses regularization, learning rate control, row sampling, and feature sampling to reduce overfitting and improve the model's performance on new data. We will use an employee salary prediction dataset for the XGBoost model. This dataset contains 500 data samples. The salary depends on different employee-related factors, including work experience, education level, completed projects, performance score, technical skills, leadership ability, and certifications. During training, XGBoost creates a sequence of decision trees and learns the nonlinear relationships between these input features and the salary. Each new tree focuses on correcting the prediction errors produced by the previous trees. Once the model is trained, OpenMathAI uses a complete boosted tree structure to predict the salary for new employee details without retraining the model. So, let's get started. Open OpenMathAI. Click Create New Project. Enter the project name as XGBoost. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for Dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the inputs and targets. There's also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually or use Smart Suggest for automatic recommendations. There's one more feature is Signal Diagnostics. There's a free columns. First one is column it's tell which features on the dataset like inputs and outputs name. Second one is VIF if it tells how much correlation of the features. Third column is status if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the XGBoost. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Train Models. Review the training configuration, test data split, which determines a percentage of data reserved for testing and validation. Click the model parameters. Boosting rounds determine how many decision trees XGBoost builds during training. Each new tree learns from the errors of the previous trees to improve prediction accuracy. Change. The value 200 means a model trains 200 trees to create a strong ensemble model. The learning rate controls how much each new tree contributes to the final prediction. A value of 0.100 allows the model to learn gradually, providing a good balance between training speed and prediction accuracy. The maximum tree depth limits each decision tree to 6 levels, helping the model learn complex patterns while reducing the risk of overfitting. And review preprocessing settings. And also another feature is added that is trained from scratch or continue from use model. If you train this model before you use that option, modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time, the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from tricks such as R-squared, RMSE, and residual errors. Model accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95 accuracy almost equal to 95%. Click Fit to Window. You will see 3 types. Fit to Window, comfortable, compact. Then the Clear History. If you click that, it will clear the history before its trained model. Another is Deselect and select All Trained Model for export. Click View Curves. You will see the diagram of actual and predicted output. Click Math and Code Preview to view the mathematical model generated by OpenMathAI, the complete XGBoost ensemble, generated source code, and training details. Open the Math view to visualize a complete XGBoost model. Maximize a window and scroll down to see the number of trees, average tree depth, average leaves per tree, feature importance, training metrics, and a complete boosted tree structure. The visualization shows how 200 decision trees work together to learn nonlinear relationships from the training data. The average tree depth is 5.9, with an average of 24 nodes and 12 leaf nodes per tree, providing a balance between model complexity and prediction accuracy. After training, OpenMathAI uses a complete boosted tree ensemble to predict outputs for new input data without retraining the model. Return to the result page and click Deploy Status. Click Export Model. Choose the required export format: ANSI MCU Fixed Point C, FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONNX Hub. You can choose any of these formats and export. You can also download the free trial versions of OpenMathAI and Twin Simulate. Thank you. Stay tuned for more OpenMathAI demonstration.